Welcome to Data Visualization in Python Part 2 for data science using Pandas, NumPy, graphics, Matplotlib, and Seaborn. Yes, here we go. Last time we covered Part 1, distribution, variant density, histogram, box plot, ridge line, and then this one. Okay, today we're covering Part 2, the correlations, scatter plot, heatmap, correlogram, bubbles, connected scatter, and 2D density. Okay, Part 3 will cover the ranking, bar plot, spider, radar, word cloud, parallel, lollipop, secure bar plot, tables. And then in Part 4, we'll cover part of the whole, tree map, Venn diagram, donut, pie chart, dendrogram, secure packing, waffle. In Part 5, we'll cover evolution, the progressions, line charts, area charts, stacked areas, string graphs, candlesticks, and time series. Part 6 of graphics cover map, that's the maps, claw breadth, hex bins, cartograms, connections, and the bubbles. Part 4 of graphics will cover the floors, code diagrams, flows, the network diagrams, the Sankey diagrams, arc diagrams, edge building. And then lastly, in Part 8, we'll cover the general knowledge, colors, interactivity, animation, cheat sheets, caveats, and 3D and statistics. Okay, so in the previous video, we covered already Part 1 on the distribution. Today, we're covering Part 2 on the correlation. Remember to subscribe so that you don't miss Part 3 up to Part 8. So we'll start with, in that order, scatter, plot, then heat map, correlogram in that order. Okay, but before we do that, if you can see here, we have so far we have just like this on the files here on our directories. So we were going to create a working directory, import operating system, operating system get, so that we see what we have, and then we'll see. Then now we create a new folder in the graphics here in the, this content, so a working folder, and then we change. We point our working directory into that folder. Then you can see it. You see that one. Okay, but this one we at the beginning we don't really need it. Okay, so we can save. Okay, then we run this one. So you can see that graphics, we have the graphics now here. Okay, so and you can see that now we have folder graphics created successfully. So it's in the content, we put the graphics, but so far there's nothing in the graphics. So if we enable the data formatter, data table, because we want the tables to be in a good format, so we use the Google Colab module, whereby we use the data table enable format. So if we do this one, so it's just not displaying anything else, it's just format, it's just making it ready, importing the module, so that from this one we can have now the file to have it here down here, the data table, table, for example, so that we can display. Okay, all right, you're using this format. Okay, now we'll upload the first file. So the file, if you upload here using the Google import files, upload, then it will wait on the screen here so that the file should go into our working directory. There we are now in graphics. So if we choose the file, we choose from our local library, then it is the Python 1 graphics, that's the data one we're going to use. So it's the CSV, Python 1, Python graphics data 1. So I'll take this one. So this is Python, then it will come here. You see now that it has loaded here. This is CSV, loaded, and then if you see here, if I do it now here, you see that now I have it here. I have it here now, loaded here. Okay, so you can see that I have the Python graphics data 1 inside the graphics, and it's in comma separated value. Okay, so you can see that this one is the file which I've loaded here. Now I can load this file into our environment, so that we are working environment. So we import these so that we'll be using. Okay, I can hide this one. Okay, so we'll have these pandas, NumPy, Matplotlib, and in particular we'll get the PyPlot library. And then Seaborn. Okay, so you know this in Python, you know what like that. What it means is doing two things at once. It is importing the Matplotlib library, and then in that Matplotlib there's also another module, submodule, which is the PyPlot. So it's the same thing as maybe import Matplotlib. Then after that you say from Matplotlib import PyPlot. So you can combine them by just using this method, matplotlib.pyplot. Okay, so this one. Okay, so then we have this one, and then we use here now. We use the pandas now. This one, the PD that we already have here, PD the pandas, and we use the method reading CSV Python graphics data 1. So it will read from here. It will read from this one, and then when we read it, what we're going to do is we are going to convert it into a pandas data frame. So the pandas data frame from here up to here, we're reading. Okay, so you read the file. So reading the file, then we take this one, this function, which is converting this file inside here as an argument to be now converted. All this one from here up to here is an argument of PD pandas data frame. So it means it will be converted into a data frame pandas class. And then this assignment we are saving it in def1. Okay, so if I run it, and then we run now the head of the def1 to see without excluding the index. Okay, so if I run, okay, if we run it, then we'll see that we have data file that one, which is this one, has got to 1, 2, 3, 4, 5 columns. Okay, 5 rows because we said the head. But if we didn't put the head here, we just print the whole data set. So which has got 150 entries. Okay? So but the first page is displaying only 1 of 25 because here we have used up 25. But if we change it here to maybe 100, we will have 2 pages. This page would have been up to 100, and the next page, if we go here, the next page would have been from 101 up to 50. Because 150 because we have 150. All right. So if you can see the species here, we've got the setosa, and then we've got the Velsi color, this color, and then we've got another one. Let me go to page 2. We've got another one, the juniper. So there are 3 species. The juniper, and then we have is on page 3. Is on and then on page 2 and page 1. Page 1 we have got this color and setosa. Okay, so that's the species. Okay, that one is the species is non-numeric, but these 4 sepal width, pectoral length, and pectoral width, these ones are numeric, and there are 40 in this case. There are you can see the real number. They allow decimal points, so they're not as integer, but they're 40. All right. Now let us maintain here the head instead of just the head. It means to just show just show the first 5. Yeah. All right. So. And now, if we go next to the scatter plot, because we said we have both, we're working with the part 2 here. So we're starting with the scatter plot. Then we go to heatmap and so on. Okay. So if we go to the scatter plot, we've got the data set. So we want to plot the scatter plot for this one. Okay. What is scatter plot, by the way? It's a scatter plot. Displays the relationship between 2 numeric variables. So you can don't use one for categorical, but one numerical, and not for textual or like that, or string, no, or characters, no. So one is displayed on the x-axis, which is the horizontal axis, and the other one on the y-axis, which is the vertical axis. Okay? And the data points that are represented by the circle by default, but you can change it when you can change the marker of these data plots. Okay? We'll see, you can customize. Let us see basic structure of the Seaborn. So using the Seaborn, you can use Seaborn, you can use Matplotlib. Okay, you can use Protray, you can use 49. Okay. Figure 1, that is the figure 1, we'll declare, and then access, we use Matplotlib, pyplot library module, and then we just put the function subplots, the method, whereby we fix height 8 wide by 3 height, and then this is for Seaborn module. So the Seaborn use a function scatterplot. Okay. So the data frame must be mentioned, which is the one which we have here, which we have just saved here, because we saved it here. This data frame which we saved, it's appearing here. Okay, so we've wrote this one as a data df1. Okay, so now that's the data set, and then the x-axis is the sepal length, and the y-axis is the sepal width, and then the color is dark blue. So here, but this color is not compulsory. The color we would leave it; it will choose its own color by default. Okay, but these ones are mandatory. Okay, and then we have we can set access set method for this access. You can set the title like this basic plot, and then you can use the matplotlib pyplot to plot now to show. So you can see that this first line we're using the matplotlib pyplot as well as the last one, but in the middle one we're using the Seaborn. All right. So you can combine Seaborn and Matplotlib, but we mean the plotting here, the Seaborn, we mean the mid part. This was the Seaborn. Okay. So, but we're just taking advantage of the Matplotlib because Seaborn is an extension of Matplotlib. It's an enhancement. Everything, the Seaborn, the Plot9, they're built on the Matplotlib because Matplotlib is likely inbuilt in the Python. So you cannot use Seaborn separately, totally independent from Matplotlib. You still have to use some features of Matplotlib. All right, like the number 1 and number 4. All right, so then you can save the figure 1, which is a Matplotlib format. You save fig and then scatter plot like that one. The resolution here, this is the name, this is the resolution, the quality, which will be high quality standard one, which is the dots per inch. So this is the printing resolution. Whereas in the digital screen maybe formats, when we are sending the videos or what they are on the screen or the pictures and graphics, with screen resolution, we use the pixels. Okay. But here for the printing purposes, we use the dots per inch. Okay, we're printing on paper. Okay, all right. So now, if I run this one, then I've saved this one. So this one, you can see this scatter plot. The title is the way we said it, basic scatter plot with Seaborn, and then the access by default, it will just put it by default away from these ones, the ones that we entered here. We can customize the plot. If we customize, we can put here the color blue, the edge red, and so on. The size 200. Yeah, so if we do this way, let us see. Then we put it as customized. We run. Then we'll see that now we have customized like this. So we have got blue inside and then red outside. You can interchange and put red inside and put blue outside like that. Then you see that to interchange. So the red will be inside, the blue will be outside. Okay, let me go back to where we were. So the blue is inside, red is outside. Okay, the size you can change. If I put the size small, like maybe 20, then you see that it will be small like this. Whereas I put okay, the size, okay, if I put the size 200, that's what we have like this. Okay, I changed the okay, so let me put back to this one was red and this one was blue, and then let me change and put to 500, for example, the size. So you can see that now they're very big like this. Okay? So it depends on what you want. Okay, it's fine. So this one is saved. You can see here, it is saved here. So how about the graphics? If you can see here, we have it saved here, the scatter plot. And then that was the one which we had before. So this one, scatter plot. And then we have now the customized scatter plot. Yeah, so I've saved the scatter plot here, but we've saved also now here customized scatter plot. So these ones we can download them. When we save them like here, it means if we wanted, we could go here and download it and use it anywhere. Okay. Okay. Now let's go on. You can control the marker shapes with Matplotlib. So there are actually lots of different shapes available. For example, we've got the circles, that's the default one, and then we've got that circle is the default one, and then we have also a S if you want the squares, if you want the pluses, if you want the crosses, if you want the diamonds, capital D, you can have also small letter D. If you want hexagon, small letter H, you can have capital letter H. If you want the pentagon, you want the down triangles, and then the up triangles, upside down, and then you have got the left triangles, and then you have got the right triangles, and many more. You can have the numbers. Okay. If you want just to see explore more of all of them that we have in Matplotlib, so you can import the markers and then print the markers, marker style, markers keys, so that you see the keys. These are one of the keys. So this is additional keys. So you can use a dot. That is a solid circle. This is a circle with inside that, whereby this one is the field circle, the dot one. Okay, you can have the comma, and then you can have all these we're saying left triangle numbers 1, 2, 3. You can have the diamond, the squares, the pentagon, all of these ones. So these are the ones we're choosing for. Okay, to end here. Okay, if you put none, it means they will not put any key, marker. That's none. Okay, you put also these at the end. Okay, so let's see now here. For example, we put it's the same one we had before, but now we put the marker using this one, which is the triangle facing upwards. Okay, fit regression force. We mean we don't want to have the regression line. Okay, the axis, we'll put the axis so that when X is you can set the X the title. Okay, as this one should have here. All right. So you can see now here that when we use the Seaborn and this marker and want the size here, then we must use scatter keywords. So this is the keyword. Okay, keywords. Then you have S keyword arguments, which is like S, that's the size, which is 200. Okay, for controlling the size, like how we had this shape here. Okay, but here we just said S when we used the scatter plot here. Yeah, but here now we're not using scatter plot. We're using regression plot. When you use the regression plot, then you have to use scatter keywords like that. But if we use the scatter plot, Seaborn scatter plot, then we just put directory, just S instead like that. Okay. Okay, so okay. Now, because these ones are for the region plot, the regression plot. So let us use this marker. So we save this one as scatter plot shape with marker like that. Control, yeah, let it save. So see that now we have got the triangle facing upwards. Okay, and the colors is orange. If you can change here the color to be red, then you run, then the colors will be red. But now this is facing upwards. If you want it to face it downwards, then do like that. Or put capital letter, should be small letter. Okay, so if you run, that one will be facing upward, facing downwards now. Okay, but if you want to put here the X, the cross, then you see that now you have crosses like that. You can see you can put here the H, hexagon. So you have hexagons like that. Okay, you see, and this was the size. If I can put 50, I control the size, they will be smaller like that. I put maybe 120, 120. Okay, and then I put here instead of hexagon, I can put here maybe now diamond. Okay, so it means diamond like this. Okay, but I can also have a small letter d. So what is the difference? I put a small letter d, you can see the diamond how they are. So for small letter d, the diamonds are like this. Whereby the capital letter d, if I put a capital letter d, diamond like this. So they're like square diamond like that. The angle. But if you see the small letter d, and like this kind of diamonds, maybe the angle is one is different. You can see. In other words, the other one is smaller, the other one is bigger. Like small letter capital letter. But again, you can see the angles that are too much thin. Okay, and then we have as well as put the times, but you can put the plus as well. So it means you have the pluses. So there are many things you can. Okay, the dot. I didn't put the dot. Put the dot. Just dot. Then what will happen is that you have the dots, circles, filled circles like that. Whereby if I put the O, this is the circle. They're different. This is the circle. The other one was the dot. The circle, it means inside you can fill something while the dot was just a dot. And then we have also, you can put, there's many here, maybe what else maybe that was trying, but in this one, the tilt, you can see tilt, so you can put that. Okay, so that's the tilt, this one. Then it will be showing like this, the bit fans. Okay, so it depends on which one you want. Okay, let's leave it, the one which we had there. It was the facing the current, the exponential power facing upwards triangle. All right, so you have saved it already, which means as scatter plot. So which is here you have to customize Python scatter plot. So they have been saved in the working directory here. All right, see this one. Yeah, so the shape one. Okay, which means you can download it, you can rename, you can delete it, and all this one into a local library. And then let us move on. Univariate. Using a categorical variable. So you can split the data as a control variable, or you can call it a sub-sampling variable. So you put it into subsamples, or as a grouping variable. So you group or you stratification variable. If you do this one, that's control plot, or sampled plot, or grouped plot, or stratified plot. Okay, so set control plot. So in that case, the same thing we were doing before. We load data sets, for example, iris. Okay, so we've loaded the iris, for example, and this data set. But this one, this data set, okay, we can as well just load the one we already have it, so there's no need for this. So we have it already. Okay, so we have the data set already. It's already in the directory now already, because up there, where it's here. So that one is repeating because we already have it here. No, it should be above. And we already the data set here. So diff one, so which means we have already. Okay, this now what we'll do is we just plot. Is it? Yeah, it's around categories and categorical. So the categorical is the spacious one. Okay, the one which has Setosa and that one. So if we run, what will happen is that using scatter plot, the one we're using, but we use now the keyword HUE in this argument with one which provides the factor of the group. So it will group exactly what we had, but now we had the scatter plot. You can see here, which had this one. Okay, all this is one thing. So maybe here I can just do like, let me do like this. Delete. Okay, that. Okay, so we have put a comma. Okay, and then I can just maybe double it. No, let me do like this. Double it. Okay, so here let me remove. Okay, like that. This one thing. Okay, like that. Then parent. Okay, it's one thing, but maybe for it to look beautiful, what we can do is like this. We can enter. Let's see. So we enter. Yeah, I want something like this. But I mean, all this is one. If you can do like this, you can see it's in one line from 5 up to 9. So if 5 up to 9 is 1. So what it means is same label. So it's the scatter plot, Seaborn scatter plot. Then we will the data point with the data frame, which is the one, and then the x-axis, the y-axis, and then you use hue. That is species, you mean group by species, and then style use what species, but you can also use another style here for the if you want. And then the style by mean is the style for plotting these ones. These are the markers style that we're talking about here. So if you just say styles, it will choose by itself from those numbers. And then S, that was the one which was giving example the size, which was like 120 here. We use also 120. All right. And then we have the parrot. So dictionary, you can use setosa. You can say setosa should be red. Virginica should be blue. And the vesicolor, okay, there were three. So we had Virginica, vesicolor, and yeah, there were three like that. But if I put them in the order they were, then this one I can put it at the end. The way they are in the data set, is what them in the order the way they are in the data set, so I can put it at the end. Okay, so this dictionary is going to be used as a color map as a parrot, so that for the photo it will be red like that. Okay, and then you can change the dictionary as well. All right, you can change it like this one which we have here if we want. Okay, so up to here, take this one out, put it here. Okay, all right. So let's see. Okay, all right. Save. Okay, then you set the axis. With this one, you have done scatter plot, and then this is another part. This is not part of the scatter plot. You set now the axis to that one, and then you save. Okay, so this one I can put on another line. I can put on another line like that. Okay, so that we see that it's not part of file. Okay, and then you save. I have to put another line. You already understand everything, and then as it's all run. So if we run, you see now what we're doing is it's using the species, so it's choosing its own. So color map here, like this one is for setosa, and then the cross is for vesicolor and virginica. That's also put at the bottom. It's for this. It's just choosing the squares and the blue inside. Okay, yeah. So this is a controlled one. What it means is last time we had just for all of them, all the data set. But now what we've done is we've plotted for setosa separately, and you can see they are on one place there. There's something common, and you are plotted for the crosses for this star, which means they're centralizing here. But you can see for the virginica, they are going to shift into the right here. It's similar like the crosses, but shifting to the right. Whereby this one, the crosses shifting to the left. Okay, so you can see that we have got three scatter plots grouped. Okay? And then each one of them can have its own line, regression line. Because here we put regression line to be false. So if you see here, the regression line, where is it? Somewhere I put regression line. Okay, the regression line. Okay, I didn't put. Oh, okay, it was before. So here I put the regression line false. Okay, I didn't show you what happens when the regression line is true. Okay, for the previous one. So when the regression line is true, you do that as well. I explained already. Then if you run, you put the Seaborn regression plot, then you put true, okay, then it will fit this line of fit here. And it puts also the confidence interval, which is 95% confidence interval. So you can see the lower limit, the upper limit. Okay, see? So you have here, and then the color also the red. That's why it's using the red white color. Okay, if it was blue, then it would use also the blue color. Right? Okay, so has put the syllable and has put baseline fit. You can put maybe the dot, the original one which we have, so that you see the original one. And we use the circles, then we do that one, so it will look like this one. Because many people maybe prefer the circles. Okay, and the control size and change. Maybe this is too big. Can use maybe 60. Then do this one, so it will look like this. Yeah, so this is when you put the regression is true. So here also down here. Okay, but this one is the scatter plot. Okay, so for scatter plots, okay, we have done what we have is this one. Okay, we'll see. We can put also the regressions there. Okay, we'll see later on. We'll put the regression lines. Okay, the heat map. Okay, the heat map is a graphical representation of data where each value of the matrix is represented as a color. So that's the so use a color. That's the you represent data by a color. So the color is representing the intensity of the color is representing something, the intensity of maybe the nature. Okay? So that's why it's like heat map. It's like maybe, for example, if it's too hot, it will be maybe very red, too much red. Maybe start from maybe something looks like maybe yellow, orange, and then the red will be the color is too dense. Then that one will be the highest. Maybe that's like heat map, like heat will be the hottest. Okay? So you can use also a correlation, for example. So that the higher correlation will probably the color which is more brighter like that. Okay, so you can use correlation matrix square, for example. Then it means I've commented from here to here so that you see first without the correlation, okay, without showing correlation. So if you see here, we have the same. We select the data types and then include only the ones which are numbers and find correction. Why? Because if you don't include the NP, the NumPy number, then it means the NumPy number. Then it means it will include the species column. So we don't want it. Okay, if you see, let me see the diff1. So if I run, diff1 has got this species here at the end. So if you run the correlation matrix, the correlation with the species, especially this one will not work. Set also so we want to exclude all the variables that are not numerical, that are not working. So that's why we use this one. We say select data types, only the ones. So select from the one, select data types like this method, only the ones which have got what? Only the ones which are numeric. Okay, we're using NumPy. Okay, so when it selects these ones which are numeric, only those ones which are numeric, then those ones, that one now, we can plot now the what? The correlation, okay, for those ones. So when we put the correlation, then we'll save it in D2. Okay? So that here now, when we can say the heat map of D2, then D2, DF2 will be the correlations matrix. Okay? So that's the one which you can plot the heat map of correlations. And then annotate true, that's you want to show them. Okay? And the color map, that is put the color map. Like this is purple, orange color map. Okay? Okay, so that it will use this one to do the intensity of the heat map using the purple orange color map. There are others also color maps. Okay, let's. Okay, so if you would do this one, it cannot work. Let me do this one deliberately. That's why I commented. If I could run this one, let me just run to complain. Let me just run this one. Run selection to complain. Why? It will complain that it could not convert string to a float setosa, something like that. So that's why I put this one in delivery. So you cannot, because there was a data type that is not required, that's string. So what I just put it so that I just explained. So this one is not needed, but this one will work. Okay. I'll run this one. Just run this one. Okay. So run this one will work, and if you can see what is the F2. Okay. So see this one. You can see that the F2 will be the correlation matrix. So which means when you just do this part, when you're just doing like that, you mean in Python it means generate a correlation matrix using what? From the F1. So it's this method that we assigned to this one. So which is the same here. If we just run this part without equals there, it's the same thing. It's just generating matrix. So this matrix is the one, correlation matrix is the one which is stored in F2. So if you can see this matrix, it will be a square matrix. It will be 4 by 4 in this case. Why? Because here we have the same things we have here to be the same things we have going down here. So going to the right here to be the same thing going down here. Okay. So you can see that here the main diagonal will be 1 1 1 1 1. The main diagonal is 1 1 1 1. Okay, here. So it's 1 2 3, and then down here also there will be a 1. Okay. So in this case, why? Because the main diagonal, where am I? Where am I? It's down. Can we go up? Yeah. So yeah. Did I show the head correction? No. So it's shown 1 2 3 4. Okay, all right. So which means this one is 1, this one is 2. It should be on the right hand side. I'm going to put something. Yeah, here. So it will be on the right hand side, which is 1. So it's 1 2 3 4. See? So these will be ones, and then these ones will be correlations. So as you can see that the first column is same as the first row. The second column, it will be exactly the same as this one. If you transpose this one again, same as the third one, and the last column will be the same as the last row. Okay. So that's why sometimes some people, they just take the upper triangle apart, or they take the lower triangle apart. Yeah, and so they can take a half matrix like that. Because the other one is just repeating the other one. All right, but now this one is a correlation matrix, but we want a heat map. So a heat map, we'll have to assign colors to this. Okay, so that's the one which we're doing here. Seaborn heat map. Okay, and then we use the color map that was assigned, and then we want the correlation matrices, the notation, these numbers to appear. All right, let me run, and then we save this as heat map correlation. So if I run this one, then this is heat map. So that correlation which we are seeing that now has been converted into a heat map now, like this one. Okay. Now, if you can see, if you go here, you can see that we're saving these data files. So you can see here we have this working file with graphics and the customized heat map. All these files that were working. That's why that was a good idea of the working directory. Okay, and this one is the heat map correlation matrix. So it will be heat map here. It was the alphabet B C D F G So it's heatmap correlation matrix. You can download it here, and then you can be using it in your local file, or you can report it anywhere else. All right. Right. So now we can close this one. Okay. All right. Then let me close. Now this is the heatmap graph. But if you can see these inside, if you didn't want them, you can say annotation false. If it was false, false, annotation false. Here, then you see that now it will show the heatmap. Just heatmap. The heatmap is about colors, coloring. Okay? And this is the color scale, which we're using, coloring style, which we're using the pool O, which means purple orange. Okay? So there are other techniques. This is the purple orange. You can have also others maps like pink. I think that one is pink. For example, very beautiful. Next is pink, yellow, green style. So pink, yellow, green. If you use this one, the pink, yellow, green, you can see it's using pink, yellow. This one, if I also put true, so that's true, true. Okay, if I run, so I'm using pink, yellow. So you can see it's putting that. Okay, so it depends on the color intensity type that you want, and it can some of them the combination of two colors, others three colors. Like this one is pink, yellow, and green. So you have combination of pink, yellow, and green, and combined together. And you can have as well. There are many. I just forget, but you can check. I mean, if you can remember another one, there is another one I try to remember. Is it blue, green, yellow? If I'm not mistaken, yellow, orange, brown, pink, right? Yeah. So this is green, yellow, orange, brown. So you see that this is the color map for red, orange, red, yellow, orange, brown. So it will do the intensity such that the highest one will be more dense, like 1960. Modified by the small ones, like this one, only they will be brighter. Like this is look at the magnitude. This is like smaller, very small one. It will be more light. See? Then we're going up to the 7. You can see this will be the same as the 7. When we go up 12, because we're looking at 12, we're going up on the scale, so you can see it's changing. Then when you go to 82, you can see it's a bit lighter. Then 87 is more darker, than 96, dark. Then 1 is the highest at the top here. So as we go from down going up, we grow the intensity, heat map. It's like the heat is becoming too much. So the dark will be the highest. Okay. I think we understood. So that's the heat map. And then let us proceed on the half matrix map. So when I have half as we want it. If you want a half, what you do is you generate the mask, so that this one, you take the NP, the NumPy, the zeros like, which means all those which are zeros, these ones you mask them. Okay. When you mask this one with 0 likes, then it means now you use this mask, and then you use NP lower triangle. If you mask the lower indices, especially this one, it means you mask the lower triangle. But we have commented this one. This one you could mask the upper triangle, so you use the U. That's the upper triangle. Okay, but let us mask the lower triangle. Then if you do the same thing which we thought the way we're doing here, but using now a mask argument. Then if you mask everything else we did, we're using whatever color map we have here. It's the color map. Here we're calling it to the same color map. Yeah. So okay, this one was purple orange. I can take it back. Okay, it's fine. This one is yellow. I just change yellow, orange, and then what? Brown. All right. So there are many ways. Okay, brown. Save. Okay, this was orange, brown. Yeah. So now this one we're using the same purple, orange. Okay, right. And then you say you call it half matrix. The half where is it coming from is going to be masking. That's this masking here. This one you're masking. This one, when you put a mask, you choose only the upper. It will draw only the upper triangle now. So you see, you have only the upper triangle. This one. You exclude these ones. So you take only these ones. Okay? Whereby if you, on the other hand, if I masked this one, and I commented this one so that I masked the upper part. And then I remove the upper part, exclude the upper part. So masking the upper triangle, then I will have only the lower triangle. So see, the lower triangle part. Okay, because why are we doing this? Because it's repeating. You can see here, the first row is the same as the first column. Okay, the second row will be the same as the second column. The third row will be the same as the third column. The last row will be the same as the last column. So they're the same things, 82, 82, 87, 87. This, you can do the diagonal like this. They are the same. Do the diagonal like this. They are the same. Diagonal like that, and that one is the same. Again, this one is the same. This 137 is the same. 96 and 96 is the same. So it's like we're repeating. So that's why you can just use, and we know the main diagonal is always 1, so it's not really needed. That's why we just remove the 1, 1, 1, it's automatic. There's no need to think. So that we just need the upper triangle or lower triangle. We call it the half matrix heat map. Okay. In other words, it's just a half heat map, but this one is the matrix. That's why we're saying half matrix heat map, because you can have different heat maps. But a heat map is just a coloring. But in this correlation, what you are carrying is a certain value. Those values you are carrying, you are putting on heat map. They don't always come from matrix. They can come from correlations. Actually, this is already the matrix correlation. They can come from probabilities. For example, you can have a probability heat map. So if you got the probabilities, a matrix, but it has to be a matrix, of course. So I just said a matrix, but we should have said correlation matrix heat map. Okay, 4. So which means you can have probability matrix heat map. Then we have the probabilities and put like that. Okay, then have the variances heat map, whatever. Okay, we call it the variance covariance. Okay, let us move on now to sequential palette. You can have only one color. So when you have only one color for sequential, you have this one, then it means you can put the plot, the number of rows, number of columns. If you put number of columns on that one, then here, like here, you have got 3 by 2, which means you have 3 rows and 2 columns. In that case, now because you're using one color format, then it means that here you can just choose that one color. These are the ones which I was saying. So this is yellow, green, blue. I've got blue, purple. Okay, you've got yellow, orange, brown, like that. Okay. If you say blues, it will be blue, only one color. If you say greens, it will be one color. But if you do like that, it will be a combination of colors. But by the end of the day, all this one is known as a one color palette, whatever. Okay. So if you use a one color palette only, then what it means is each of them you can specify. Like for example, you just want you to see. So this first one, that is 0, 0. You mean on the first row and the first column. Okay. 0, 1, it means you are moving the columns, which means still the first row, but the second column. Then, because there were 2 columns, you have exhausted. Columns are 2, which means you end at 1. Then you go another column, another row 2. So 2 index will be 1. So 1, 0, and 1, 1. That's you have exhausted the second row. Then the third row, to index 2. So 2, 0, that's the first row, column 1, and first row, column 2. So which means you've got 1, 2, 3, 4, 5, 6. It's 3 by 2. So if you can see, it's the same thing, but we're just changing the colors here. We just wanted to see the sequential palette on color maps, how they look like, all of these ones. Okay, all right. So let me run. So if you see, okay, let me run. What will happen? Okay, so we run. Yeah. So what will happen is that we just wanted to see that this one, when we use the yellow, green, blue palette, it's this one. It's using one palette. So it's this one. Okay, to look like that. Whereby if you've got blues only, because we are the way we are doing here, 0, 1, 0, 2, 0, we're moving row by row. So we go, this one is blues only. So when it's blues only, come up with that. That's for blues only. And then for cool one, see this one. So for cool one, it will look like this. Okay, that's one color, but that's right. So you do for this one, this is what? This one is the blue, purple palette. So you'll be looking at this one. And then this one is the yellow, orange, green, brown. I think I used it already somewhere. Yellow, orange, brown. So this one will be here. This is the orange, brown. And the last trait, this one should be the greens. Okay. So this is the greens. Okay. So we're just trying to show that you can choose any one you want. But we're putting it here on a grid of 3 by 2. So 3 rows and the 2. That's how we do the graphics. When you want to grid them, you say you use support in Matplotlib, you say this axis on that figure 7. You say number of rows, number of columns. All right, but I was just showing the one color maps. What about you can have divergent? Okay, color maps. Okay, divergent is down here. If we go to divergent, what about the sequential palette with minimum and maximum? So you can here we're just having the one color map style, but we did not have limits. So we are plotting everything on from what? From 0 up to what? 0 up to the end, which is up to 1. Okay, because the correlation is from not just from 0. From -1 up to +1. Okay? Because with plus or minus, 0 is in the middle. Okay, but here it means the smaller west was 43 minus, so that's why we don't have maybe -1. But if we had very small probabilities like minus 0 point, maybe 0.2, then here down would have gone up to -1. So not 0.2, minus 0.98, for example. If we had minus 0.98, we would have this one would have again a 1, -1. Okay. So it has been scaled itself because it knew that there's nothing at the bottom because of it from -0.4. Okay, yeah, but if it's in full, if your variable data set will be from -1 up to +1 for correlation heat map. But if it was probability heat maps, you to the lowest yield will be from 0 up to 1. So again, here you can control the ranges. For example, if you want minimum and maximum, maybe you just want to say you want to concentrate on like this one. So you have used a 2 by 2 column, 2 rows by 2 columns. Now this one, I say greens in first one, reds second one, this one pink, yellow, green, and then the yellow, green like that, 4, but 2 by 2. But I'll put this one from 0 up to 1, the other one from 0.5 up to 1, the other one from what? From 1 up to from 0 up to 0.5 like that. See? And then this other one from this one. But if I wanted also, I can put maybe negative as well. Okay, so let me put a negative as well. Maybe, okay, let me first land this one. I'll put negatives. So we mean minimum and maximum. So what happens? What we're saying is the first one we put only from 0. What it means is we use the color map only from 0 up to 1. What we're trying to say is we're restricting the color map, okay? Because the color map in full should have been from -1 up to 1, but we'll start it just from 0. Because you see here the full one, like here this one. Okay, which one are we using? First one. We're using the greens. Okay? So you see the greens, first one, which was this one. We used it here. Here we use the greens here, but it was in full without limit, no minimum, no maximum. This one, so it started from -1. Of course, because by default, because the values here, we don't have -9, 0.9 or negative 0.8, something. That's why it's just from here. Because the lowest is 43. So it's just 43, which will be somewhere down here. That's why it's that's why it's showing here -4. So, since we started from what 0, it means it will ignore this coloring. Okay, to start from 0 up. That's what we're saying here. Start from 0 going up. See the coloring style. Okay. So in that case, if starting from 0 going up, it means these ones, the other ones which are below 0, it will be no colors. It will just be no color. The default will be like white, okay, or no color. This fill no color. They will not be filled with color. See? So all these ones which are below, we put a minimum just from 0 up to 1, which means anyone whose color is below 0, it will be just white. See, you understand? Whereby this other one on the right hand side, okay, go down. No, where's the other one? Yeah, this one on the right hand side. This is from half to 1. So which means it will just take from half up to 1, which means anything below half will have no color. Okay, in other words, not really will have no color. I should explain very well here. Sorry, apologies. No, not will have no color, but all those which are below what the minimum, they will just take the color of what cell. Okay, that's what I said. So like here, all those which are below 0.5, they will just take the color of 0.5. So this that color of 0.5 is the one which will be color of all those below it. But those which are above 0.5, like these ones, they are the ones which will now start show from this color. Similarly here, if you say from 0 up to 0.5, then all those which are below 0 will take the color of 0. So these ones will take the color of 0. But starting from those which are above 0, those which are above what? 0. Now, those which are above 0, but up to 0.5 only. They will take what? They will take this, they will follow this parent, this color style. But the moment we reach again 0.5 now, because these two we are reaching up to 1, this one up to 1, but this one now will receive the upper limit, we reach only up to 0.5. You see, if this one was ending at 1, this one was ending at 1, but this one is ending on at 0.5. Okay? Because we restricted here to say up to from 0 up to 0.5. Okay? So this one, we put it in the what? Axis 1, 0. This one I've already explained about axis 0, 0. It means first row, first column, first row, first column. Okay. Here that means first row, second column. This one, this means first row, sorry, second row, first column. This one means second row, second column. Okay, because index is from 0. Okay. So once again, 0, 0 will be first row, first column. But here it will be first row, but second column because index starts from 0. Here, so it means it's in first row, we finish first row. We go to second row, we finish second row. Okay. Whereby if we go to third row, we use 0, 2, 0. 2, 0. This one here was first row, we have finished. Second row, we have finished. Third row, we have finished. Whereby the top one is the first column, and this one is the second column because there are 2 columns. All right, we understood about the grid. Okay, now we are here. We're saying minimum and maximum. So we're saying 0 up to 5. So it means those which are below 0, all of them, they will take the color of 0. We'll explain that here, 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 here. And all those which are in between 0 and 0.5, they will take these colors, which we have there. But the point is, you can see that all of them are here, they're just like the same color. Why? Because all these ones here, it was simply they're above 0.5. These positives, all of them are above 0.5. So if they're above 0.5, then they will take the 0.5. What about if I just change it here to maybe 0.9 so that you understand? So if I change to 0.9, 0 to 0.9, let me run again, 0.9, changed. Okay, so if I run again here, let's see. So it's from 0 up to 0.9. Okay, then as I've explained, all those below 0, these ones, they will remain, they will explain, they will take the color of 0. All those below 0. But all those in between here, they will take the coloring according to the palette here. Scale because of the scaling of the coloring, okay, the intensity of heat map. But all those above 0.9, like which one? 0.9, this one, the 96, these two. You can see this one, 82, 87, they will take the colors here. Okay? But when we go to all those above 0.9, okay, the 0.9, all the above 0.9, that is this one, 96, they will take this is the 96, 9.96.96. This one up to 1. No, I'm looking at the wrong thing. It's here. Okay, so all those which are 0, below 0, they are correct. Okay. That's what I was wondering. I was looking at the wrong figure. Okay, then all those between from 0 up to 0.9, they will take this correct scale. But if you look at the 0.96, it's above 0.9, and then the 1 is above. So all these ones, the 1 and the 96, they will take the 1 to 0.9. But the 87 and 82, they will take according to there. You see now. But only these ones, they're taking above there. See what's happening. Okay. If I wanted, I think I've understood. Okay, let me go now to this other one. This one was saying from 0, from 20.25 to 0.75. So the 75 and 25. So it's the same explanation. All those below 0.25, they will take this color. 75, these ones. They take color minimum. And all those from 7.75 going up, that is all the 87, 82, 90 watt, even 1, all of them, they will take the color of the top one, but will limit. You see, that's why he was just saying 2 colors. Correlogram. So the correlogram, this is the correlation matrix, allows to analyze the relationship between each pair of numeric variables of matrix. So the correlation is visualized as a scatter plot. Okay, so it's the same way as we've been doing with before, but now instead of plotting the correlations on that heat map, we're using a pair plot of the correlations of the scatter plots now. So if you see the basic one, we can use the pair plot. We use the pair plot, then the data set, and then the diagonal kind kernel density estimator. So which means the diagonal will be in this case the diagonal will be the kernel estimator. You can see. So what it does is it plots in this data frame. When you use pair plot to already choose the ones which are numeric. So it will exclude it's any build to exclude the ones which was called the specials. So we have already sepal length and we did a scatter plot, like that scatter plot. But here, because we've got the sepal length and the sepal length, it cannot be a scatter plot, it will be a histogram. Or it can be a histogram or a kernel density estimator, this one. Okay, so the main diagonal here we had 1, 1, 1, 1, 1, 1. This time we have got the kernel density estimator. Okay, it's just a matter of changing here. If you wanted the histogram, you just put kind histogram. Kind histogram, then to put here the histograms. See now the kind it will be histogram. So you can see that if you just put kind histogram, that means all of them will look like the histogram. See, all of them will look like histogram. Then it's only in the middle, in the horizontal of this one, the main diagonal where we do a pure white histogram. Okay, if you set kind kernel density estimator, okay? Kind kernel density estimator, okay? Then it means this will be the density estimator on the which is the probability plots on the what on the middle here. The kernel the density estimator on the middle, but here it will be doing the contours on the other part. Here it will be contours. Just a kind that one. So it's up to you if you want that way, you do like that. While if you put histogram, it does like this. But what many people like, they do not like this way. What people like is they will put diagonal kind. Okay? So for diagonal kind, histogram like that. This is the one which now by default it will do the what scatter plot, and then the diagonal only will be the histogram. So it's either the diagonal only can be histogram or the diagonal only can be kernel based estimator. So that's we say diagonal kind, not just kind. When you just say kind, that's when you add the contour like that you have like that. Whereby if you just say kind, then this one will be contours. Okay, so histogram. Okay, now all this you are saving here, that's basic correlogram Seaborn, things that have been saved here. Seaborn basic, you remember the basic correlogram Seaborn that have been kept saved here in the graphics. Okay, now let's go here. Basic correlation but with regression. Because these ones we don't have regression fit here. So we can put regression right here. How do we do this? We use kind regression. When we say kind regression, then put what regression line, and then diagonal kind histogram. Okay. So if we do that way, we'll have on the scatter plot we'll have the regression lines like that. So we use regression lines on this one. But if we wanted these ones, we would put, that's why I flagged here. We could use this one. The histogram, we could use the kernel estimate, but with regression as well. If you do that way, then to do the same regression on the this one, not down. To do the regression there, but here it will put the kernel estimator. So it's up to you. So others they prefer the kernel estimator, others they prefer the what? The histogram. We can use maybe histogram the way it goes. Okay. So here I want histogram. So we have the histograms like this. Have the histogram like this on the main diagonal. Okay, and then this one will have what the regression. When you say regression, you will scatter plot but with regression. Okay, that's exactly what we did. So from the beginning, somewhere here, we had to remember here, yeah. So it was if it is regression true. When you use the regression plot, we say fit regression true. But when we use the not the regression plot, now here if we use the pair plot, yeah, we down. When we use the pair plot, then we have to say kind regression. Okay, so that's like that. Okay, what about for we control for grouping variable? So it's something like that, but we group. That means we use hue always. A group in Matplotlib or Seaborn. So if we use hue, that is species. It means HUE. It means control for species. And then markers. It means setosa. And then the other one, which is this. And then the genica, those ones. You put them with these markers. You can change these markers, of course. The palette you can use what color. We were talking about divergent colors or whatever. One color style or contrasting styles. So you can use what? Set one. Which is kind. I will explain that one. Okay, so this will group. And then because you have not put the regression here, there is no regression. So it will not just put the scatter without regression. Okay, that's two. And it will save it as grouping. So you can see we have got like this. So in this case, it's different from this one, whereby we were just doing all of them. But now what it's doing is it is separating the according to species. So you see the color here, the red setosa, which means setosa would be red. So to do setosa separately, and then this one is separately. I think that's what we were doing last time. Okay. Now you can see this one is a matrix. When we talk about correlogram, what it means is again the first column, first row will be the same as the first column. The second column will be the same as the second row. So it's just like the way we are doing the correlations. That's what I think maybe I'll put later. So this one will be the same as this one. Okay. The only difference is that the axes are interchanged. So what do I mean is that here, the one which was on the x-axis is the if we take like this one, the one which is on the x-axis is the sepal width, the sepal length, versus sepal width. So it means sepal width is on the vertical, but when we take this one, the sepal width will be on the now will be of the horizontal. So that these two graphs there will be a reflection in the y-axis. Okay. So reflecting. So what we mean is that it's like this one becomes here, and this one goes up. That's how we do that. So this one goes up, whereby this going up goes from horizontal like that. So that this point, which we are seeing here, these 2 points like that. These points here, they will be doing like that. They're different. What will happen they will look a bit different. Okay, because I can just say that these points are looking like this. They are looking like horizontal. These 2 points here, they will look like vertical. You understand what I mean? These ones here, they look like vertical, like a line here, going this direction. 1, 2, 3, going like this. Here, it will be the same 1, 2, 3, but going like this, horizontal. Okay. Whereby here it was 1, 2, 3. Okay, I was talking this one. While we're doing vertical, 1, 2, 3. Here it will be horizontal, 1, 2, 3. But the one which I was saying vertical, this one was this 1, 2, 3, 4, like this. It was going in this direction, but here it will be going. It's the same direction, but they're different. It's like the one which was down here will be on top. So I think you understand. It's like this axis becomes this one. Whereby this going up comes towards the right. That's what happens. So it's like this graph you are seeing here. You go the other side and see it from and see it from the other side. You go to the other side and then orient it or rotate it 90 degrees. Okay. Now, if you wanted these ones histograms, you just change here as well. Just change here histogram. That means this and the diagonal will be histograms. But where am I? Not here. I do not want here. I'll change it on small on the wrong place. I'll change here. Oh, it's only histogram. Okay, don't know what I was explaining. Okay, let us move on. Then here, I wanted here. Okay, so I mean here, if you change this one to instead of having histograms, change to histogram. No, kernel density estimator. Okay. Then these ones. Now what will happen? We will have like this. Okay, this is the one which I commented above. Kernel density estimator. Okay, so I just undo. This is the one which I commented at the top. We have got kernel density estimator to do histogram here. We have got kernel density estimator. So in that case, you will have like this. Okay, you should remember last time. If I think again, we had the horizontal on these ones, which means the red one, this red one will be for setosa, and then vesicular and viginica. Okay, so they're like stacked bar plot. Okay? But when you use the other one, they become density functions. Okay, and density plots, and then the basic correlation but using Matplotlib. So it's a bit complex. There's no inbuilt like in Seaborn, but here we write a bit some code. Okay. So we create the grid, like the columns. For these columns, we lay the grid 4 by 4, 4 rows and 4 columns, and then we write a code like this. Okay, so if you can see, it's a bit complex. So we write a code like this to say what we're saying is Matplotlib library. So by pyplot. So what we can do is if I say 4, then the columns, you fix the columns for I in the range length columns, and then for j in the range length columns again, which means this part, you say that if the I is less than j, it means if the upper triangle, if you want to fill in the upper triangle, then you add the scatter plot for each group in the upper triangle. So if I is less than j, that's the upper triangle. Okay. Whereby if the I else, if I is greater than j, okay, which means the row is greater than the column, which means it's a lower triangle. What we mean is like here, these rows, this is row number 1, this is row number 2, row number 3, row number 4. Where the columns number 1, 2. So here what we mean is 0, 0. Here it is 0, 1, 0, 2, 0, 3. 1, 0, 1, 2, 1, 1, 1, 3. 2, 0, 2, 1, 2, 3. 2, 0, 2, 1, 2, 2, 2, 3. Here this one is 3, the column number 4 is 3. The row number 4 is 3, 0, 3, 1, 3, 2, 3, 3. See? So there are 4 by 4, which is 16 points. Now, the way I was saying there, it's like when you talk about upper triangle, it means I is less than j. I is row, j is column, which means here, row, this is row number 1, okay, which is 0, index 0 for row, which means for column here they are equal, and j are equal 0, 0. But going in this part, it is I is less than j. Because I is 0, 0, 0, 0, 0, but j is 1, 2, 3. That's why this is upper. Similarly here, if the row second row, it means starting here, that's when I and j are equal to 2. Sorry, 1, 1. But starting from here, it is I is less than j. That's why when I is less than j, we talk about the upper. Whereby when we talk on the left, this is row number 3, which is 2, 0, 2, 1. So I is greater than j. Okay. But here I and j are equal, whereby only this one, that's where I is less than j. Okay? Or 3 is less than 2 is less than 3. So this one will be upper. That's what we're talking. That's the language we're talking about here. Here, okay, for the upper triangle, lower triangle, and then the main diagonal. Main diagonal. That's why the indexes are the same. Okay. So when we do this way, then this we brought or as we did above, but as we did in this one was in Seaborn. In Seaborn, we don't do any match code, just a pair plot. Seaborn knows itself. But for Matplotlib, you have to do this way. There's nothing like pair plot. No, we do this way. You need to do like them. But the good thing is that Matplot again does beautiful things. Only that's complex. Matplotlib. So you see how good it is. And if you wanted sub-samples, but same with Matplotlib, then it means you want out sub-samples. Then it's the same thing we've done, but now we do something more additional. We had the 4 here, this is 4, 4. Then we had the if, you remember here, we had the 4, nested 4, 4, and another 4. For column, when we're getting, we take a row, and then we traverse column by column. And after that, we use these conditions. Okay, we take a row, like row number 1, then we move columns up to the end. We do this up to here. Then we go another row. We move another row there and travel through this another row until we finish all the rows. Now what we have here for subsampling, it means we have here we just had only the columns only was enough. But for subsampling, we need the spaces, the one that we use for subsampling, and the color that we're using to in that other spaces. So which means when we had that one, we fix the column at the row. Then this one which we had here, which we are doing for the column we do in that row, then that one inside, if it is the upper triangle or lower triangle or main diagonal, inside here we put another for loop. This one we're doing now for the subsample. Okay, along that's for the subsample in each column. If we were fixed the row in number 8, and then that row we get from 9 up to the end 26, which we were doing for each and every column J. Then we were for column and rows we're using columns because when we're doing this matrix we use the same names. So we use the same vector which was known as columns. The same vector we use for both rows and columns. So don't get confused. But the I is standing for rows, the columns are decided as rows. While the J, the columns are decided as J as columns. Here the columns are decided as rows. Here the columns, these variables are decided in rows as row variables. While here as column variables. That's why it's column, but the top part is for variable for rows. Okay, column because we said column. If we didn't want instead of saying column, okay, would have said maybe variable. Maybe it would have been another way. So variable, maybe is column. Okay, I think that would have been another way. Sometimes someone can say that column. Okay, so we have said variable, but we need here the variables were entered in rows, here we entered in columns. All right, I think I've explained that. Columns stands for variables, but the I here is 1% for rows and J for column. Okay, now this one here now it means you are saying that color for species and color in zip. This one when you say zip, it means when you say zip, it means to pair. It means the species to take a species here, and in the color it will take a corresponding color. So what it is, the first one will correspond with setosa, and then and in setosa the first species will correspond with color red. Vesicolor will correspond with what? Blue, and the genica will correspond with green. That's the meaning. That's the meaning of zip species colors, and the species colors in zip, that one means correspond. Okay. So in that case, then it means it will take when you take species. What it means is you filter. When you say here, when you say df1 species equals, it means where. This means it means take df1 where this one inside up here is where. So take df1 where df1 of species, which means where the column where we are in the species column of df1. It is in species. What it means is the species inside here. This other part species is a variable in the data set, but this other species what will be now this one species which comes from this species, which is what setosa vesicolor. So it means to filter the vesicolor with the genica setosa and plot it and plot a graph there for that color, and with that color then because it's zipped there, then it does for what all those 3. So to do 3, and then ij here it means because we are dealing with that row and that jth column. So it means choose the axis for that axis, ij, that axis will be here. And then what? Scatter, draw a scatter there, which is the data for using this one, which we have here now for species only, which is 2. Then to plot here, x1, columns, you see, all of them are using columns, that's why I said they use variable. But the I, it's one which is from column, and then j, this is from what? From row, I for row, and j for column for one. And then color, you see color, the other color is for the color that we use the argument in this scatter, dot scatter. But now the other color is this color. The way we're doing expression specifically, the other color which you get from the colors corresponding zipped with setosa red. So, and with this opacity 0.5. So it plots this one for each species. So the def2 will be keeping on changing. Because when species has changed, def2 will change and then it plots that. So it will do this one for all the three groups for this upper triangle. And then we'll do the same for the lower triangle. And then we'll do the same for the main diagonal. Alright. So what it means, what it means is now we have like this. So which means we have, as I was saying, this one will do, we have the color map. Okay, we'll not put the color map, but if you wanted, we would put the legend on. Okay, so you can put the legend, show legend, to show legend. Okay, show legend. Okay, it's fine. So what we meant is this one is a tosser, and then the green one, you see, the green one is the blue one is this color and this color, and then color, and then the green is what we change. So green at the end of the G. So that is how we'll do at the here on the main diagram. But as for this scatter plot there, then to do separate this one for the torsa, this one for the ginica, and for the scora. See, I will those colors, scatter plots. See, if you wanted these ones to be the by default it uses histograms. But if you wanted, as usual, you would change on the main diagonal. What is it? Main diagonal. Bubble plot. A scatter plot where the circle size is mapped to the value of the numeric variable. So what you can do is just choose another one, which is the number 4, Python graphics number 4. This one, if we see, this is number 4. This is the Python graphics number 4. So this one, we can see this is the 2 now. Python graphics 1 and Python graphics 2. Okay, these others were the graphics. These are the data files. Yeah, so it's commercial CSV. All right. Now, if we see, if we can see the head of this file, if you can see the whole file, so not head but whole file. So you can see it is the product ABCD like that, and then I got the cost, production cost like that, 150, 180 like that, and then I got the revenue. So which means you want to see the relationship between the production cost and revenue, which means you do the scatter plots. But now you want to mark this scatter plot instead of having just the dots, the circles, for mapping instead of having the points. For the scatter plot of cost, production cost, revenue, then you make the proportion of those circles, of those sizes, of the dots, or whatever, of the markers, the proportion to market fair, which is a fair numeric variable. So like the one which has got 100 here, right here is the highest one, or the largest what, biggest what size. Whereby this one with the 30 will have a smaller size, or the biggest should be 120. So this 120 will be the biggest share, will take the biggest share of the size of the what, of the points. So when you just have the correlation, the scatter plot between these two, cost and revenue, it will have uniform size of the dots. But now we make the size of the dots to be proportional to the third variable, which is a what, market share. That's no bubble plot. Okay? That's no bubble plot. Scatter plot, it's a scatter plot, but instead of having equal sizes of the dots, those dots of the circles of the markers, those markers, those circles, those dots, instead of being uniform, they are being put proportional to the what size according to a measure of another numeric variable you want to see. All right. So that we're not just interested in the relationship, but also the magnitude of the relationship, the intensity, okay, over another variable. Okay. What we mean is so for example, what I already said. So we do a scatter plot between production cost and revenue. That was the one. Third variable called it size. The size of the what? Of the plot or of the circle of the marker. Okay. So sizes 0 up to 100 and that one. Okay. So you set X limit and you set Y limit, and you can set what the X title, and as well you can set the what, the X labels, or you can set the Y labels. Okay. So let's do it. So like this. So it means if it was just a scatter plot without the size, let me remove the market share, the size. I remove the size, run it. Oh, I should have no comma. I run it, then it will be simply scatter plot. Hello, just a scatter plot like this. There will be all 4 sizes. Okay, this one maybe let me give it size 2, but it's small. Height. Okay, so you see, if I just say scatter plot, and then I'm using the data 3, that is plot figure 14, and then I just do scatter plot between these two things. Then it will be just like this. See, that's a scatter plot. But now we've put a third dimension whereby these sizes should be in proportion to a third variable, to a third what numeric variable, in this case, which is the market share, like that. Okay, we'll put a third variable market, which is entered as size. Then it means now the bubbles are according to size of the way we have the sizes here. So that this one, the first one, the one which is the 150, 400, has got the largest, the biggest one, which is this one. See? And you can see that this one at the end here is smaller because it is 40. Then we have 2D density chart or 2D histogram with Python. So these chart types allow to visualize combined distribution of two quantitative variables. Okay. So you need to import the Gaussian estimator module from Spice Stats, which is the Gaussian estimator, so that this one is the one which you put what KDE, and then you need the from this you need also the NP random multivariate, so that you sample from the multivariate normal, which will have the what mean vector, and then we'll have the what this one the variance of variance, these ones, and then the number of what what your points that we are sampling. So then xy and theta t, okay, you transpose. So you transpose, and then you get x what y. So you transpose this one. Okay. So when you do this, then you create the filter plots, axis 3 by 3, and then you plot x, y, and then when you plot it, there will be a lot of overlapping. So we use what KO, and then we'll have the everything starts with scatter plot. So you have the scatter plot first, and then after doing the scatter plot, then you can put now the bins, the hex bins, and then after the hex bin, this is the hex bin. Okay, after putting the bins there, then now you can put the what histogram. After putting the histogram with the scatter map, then you can have now the Gaussian KDE, okay, which you use from that Gaussian KDE on the data transpose data, and then you get you plot this one, the hex bins we had there, but here we plot for the Gaussian what KDE on a regular grid. Okay, then for this we plot now the density function, the 2D density function. Okay, so this is the one. And then we're going to add some colors there, meaning the shading. So we do the shading color type, and then with the certain map, and then we can put the contours as well there, and we can have the contours with the color. It's just the contours by default, but when the color maybe red, and then we can save these figures to the still charts. Okay, so it means you have how many? You have 3 by 3, 9, about 8. So you put the scatter plot, the original one. This is the original scatter plot we had here. This one, where was it? There are 6 plots, so create a figure with 6 plot areas. Okay. So it's 3 by 3. Also, it's not just 6 here, it will be 9 plot areas, so it's 3 by 3. And then we have the first part with scatter plot. The second part, we have a scatter plot but with some colors. This one was just a scatter plot. Then, but if we see this scatter plot, the first one, it was too like overcrowded like that. You don't really see nicely. So what we do is we can use this the edge color background so that it looks with the color so that we can easily see. And then hex bin here, that's the number here. So we can have the hex bin like that. And then we can have the this one, the 2D histogram, and then we can have the what we calculate the kernel density, Gaussian, the Gaussian kernel density estimate, and then we can have also the what the density, 2D density with shading, and then we can also have a contour. So this contour is by default coloring, but we can have also our own color that we want. If we want it red or whatever. So all these ones that are explaining about connected, about contours. These are the 2D density, that one, but not with connected. Okay, I think I missed connected. So this was 2D density. Okay, the connected, I missed the connected here. The connected scatter plot Connect scatter plot, a line chart where each data point is shown in a circle. So you just connect. So this one missed is not a lot. It's only that when you work with production, the revenue, and or the market share, if you plot them, means you have them connected. Okay, so this is a line plot but connected. So it's like this. Okay, so I skip this one. So this one will call it connected scatter plot. So we have this one for the revenue, with this one for market share. Why? Because they are sharing the same access or with value there, but here they are on the product cost again it's the same, but both of them they got the production cost and the value, but you are doing for what? For the because we're doing production cost versus revenue, market share. Okay? So since we got production cost here, but here we got the values of revenue and the values of market share. So we want to see the revenue and market share how they are linked for each of the products. Okay, so that's why we're saying that here for this part we brought this access, we brought for the revenue versus production cost versus revenue. This is horizontal, this is vertical, and you have the color style, the line map, and that one. And then we brought another one. Okay, Bruce, you can comment this one. Okay, you can comment this one. If I run, it will brought only the production versus revenue. So it will be only production cost versus revenue one. Similarly, if I commented this one, it will brought only the production cost versus market share. And so the production cost versus market share. But if I want all of them, that's why I put one after the other. If you can put 2 or 3 or 4, then each one is put in a line. If there are 3, then you would have another line there. If there are 4, you would have another line. So you can have multiple lines there. These ones are known as, but they are connected. These are known as connected scatter plots. All right. So by the end of the day, we have finished. This part of correlations. And this part 2, we have finished the correlations. So we've done the scatter plot today, heat maps, correlograms, bubbles, whereby you will be using inside the third marker, the third size as numeric value to show the portions of size, and then the connected scatter, and then the 2D testers. All right. So next time we'll go to ranking, whereby we'll have the bar plot, spider plot. In case you've not heard about spider plots, we'll see what is spider plot. The white cloud, the parallel plot, lollipop plots, and the ranking plots, and then the circular bar plots, and the tabular ranking plots. Okay? So I think these ones are very common. Bar plots, the spider plots, right? And then we'll cover as well the part of the whole, the tree maps, event diagrams, and the donut, pie chart, dendrogram, circular packing. So with circular bar plot, but we have also the circular packing and the waffles. Yeah, so this will be the next video. So check for data visualization in Python part 3. Bye.